new concept, but before we get started, let me make sure I have my timer in front of me. Just wanted to see by the show of hands, how many of you have dealt with broken data pipelines? Everybody, yeah. It's a thing, and data pipelines suck. I know that firsthand because I created some of those. So why they suck is actually very interesting because I've spent a decade trying to enable customers in using data pipelines through my previous life at StreamSets. What pipelines do is essentially enable the transport of information from the data sources over to data consuming systems like data lakes, data platforms. And typically, you have these data sources managed by domain teams that are running, their very specialized business processes, often in silos. They are disconnected from the overall data strategy for a good reason, because they're far removed, as you can see from these brick walls that I drew in between. They're far removed from the overall data strategy. And oftentimes, they don't quite fully understand how their data is actually utilized. But what they do get is a lot of feedback around what they can and cannot do. And this is coming from people who do not understand the ground reality of those systems, whether it's Salesforce or whether it's NetSuite or whether it's a application running on, Postgres backend and so on and so forth. They constantly are subject to this massive amount of change management, which they don't fully comprehend and understand. And some of it is, just driven out of pure caution in trying not to break downstream analytics. So you lose business agility right at the ground level by arresting these teams into this inertia of change management. The IT teams and data teams play sort of the middleman between the data producers and consumers by building these data pipelines, which have extremely fragile connectivity to these end systems. Why? Because these IT teams and data teams, they're not the ones owning these end systems. They don't fully understand how these systems are mapped and maintained, but yet they're responsible for making the connections. So they make the connections on one end, get the raw data, and send it over, to the data consuming systems. So in the process, they become the bottleneck. They're the ones who are typically called for, when the pipelines are down. They're firefighting all the time. They're crushed in between the data producers and consumers. And, this leads to, I've seen in worst cases, I've seen situations where these people who own pipelines end up being burnt out, not because of anything that they're doing, but the fact that the complexity on either side of the fence that they're bridging is out of control. The data consumers themselves don't have a very good time either. They are fundamentally dealing with abstract dumps of information that they have to then go through this excessive process of transitioning from bronze to silver to gold in a way to recreate the reality of what those data sources were. And this process is extremely fragile. It creates these hidden dependencies, and not to mention the amount of excessive governance that it takes to run this massively complex cross-enterprise infrastructure. Pipelines themselves, have a very fundamental flaw, and I know some of you may think about it consciously. I do, because I worry about pipelines all the time. But if you break down what is it that they're responsible for, they're responsible for bridging the information gap between source systems and data, consuming systems. So data itself, if you were to put it under the microscope, can be factored into three things: the data value, which is the scalar, aspect of data; the metadata, which is, the context and the specific data type that it, represents the information about data; and then there's a semantic interpretation. Pipelines do a great job of transporting values because, that's the easiest thing anybody could do, just copying things over. They do, I would say, acceptable, but in some cases not such an acceptable job of metadata. Why? Because they are hopping across systems they don't fully own and comprehend or understand. So if you're going from a system that has a date and time type to a system that has a date and a timestamp, you're now going to have to deal with some complex logic. If forget even a data type incompatibility like that. If you're going from a system that has an enum that is represented by an integer, if you don't do the lookup transform to get back what that enum was, it's going to show up as an integer on the other side, and somebody's going to scratch their head asking, what exactly does it mean? So yeah, there are these gaps over, for metadata, but where it absolutely fails is the semantic interpretation. So effectively, whatever is it that the data pipelines represent, the data represents is lost. The pipelines don't do anything to carry that over. So your data consuming teams are left to recreate this reality. It's almost like if I like a dish that I have, in my dinner, and I use a data pipeline to get me the recipe of the dish, the data pipeline will give me the telemetry of the chef's kitchen for the last 17 hours. And now I have to recreate that recipe. And good luck, because there'll be gap in understanding. I work at Tabsdata. We are introducing PubSub for tables. It's a new paradigm for doing data propagation for the purposes of data integration across the enterprise. And this is how a deployment of PubSub for table changes things. You still have your data sources that are spread all over the enterprise. You deploy Tabsdata and you enable your data producers to publish tables. And these tables effectively are semantically consistent, ready to use, well-governed data sets that are available in the staging area that Tabsdata is. It allows the data owners to be insulated from the reality of their source system. So if I'm running a sales organization and I have Salesforce, instead of having a pipeline that blindly reads the 175 attributes of my forecast object, I'm actually going to give a very simple table that's easy to understand, self-describing, that represents my forecast. And I'll refresh it every week. And that becomes a lot more simpler, kind of going back to that example of telemetry of the kitchen versus the recipe. I can give you the recipe. And that's what this empowers. This enables the domain teams, the teams that own your data sources, to have that agility to constantly change things as they need, as long as they understand what is it that they are on the hook for sharing with the rest of the organization. So it automatically enables them, it pulls them in the fold of alignment of the data strategy that the overall organization has. The data and IT teams themselves are no longer, have to worry about connectivity and engineering overhang of managing, different systems and their downtimes and such. All of that becomes pushed down to the domain teams. And as a result, what these data teams and IT teams can do is focus on enforcing the SLA, implementing, the data contracts that each of the domain owners are responsible for sharing the rest of the organization. And then part of the tooling that they get with this is the ability to have full provenance and reproducibility, replayability of every decision, every transformation that passes through the system. Why? Because by definition, PubSub for tables uses tables as a unit of work, which gets versioned every single time the table refreshes. The data consumers have a much easier time. The overall costs of your data platform in terms of the storage overhead, the latency, the IOPS, the compute, all of that goes down remarkably, because guess what? You're getting gold data. You are getting ready to use semantically consistent data across the enterprise. And so you don't have to worry about reimagining and recreating that recipe. And then, of course, it becomes self-service with clear ownership, a line of sight to who is responsible for that data. So this is a world where you have data pipelines replaced by PubSub for tables. It's almost as if those walls didn't exist. So what it does is, as compared to data pipelines, it also does, PubSub for tables also does a remarkable job of transporting values, because they're just the basic things. But it also gives you this consistent metadata along which the internal domains can communicate and collaborate with each other. There is no more inconsistency. Data teams can enforce that. They can create quality gates using transforming functions to block things that may not meet the quality requirements or consistency requirements. This can happen in stream by a third-person oversight. And most importantly, these are consistent and well-formed data sets that are ready to use. They're well-governed. You're not going to get data falling in the wrong hands. And as a result, you have so much more agility, you have so much more efficiency, and you reduce the costs quite significantly. And that's just the tip of the iceberg, because guess what it does is it takes your the complexity completely out of the fold. You have empowered your domain teams to own and share the data by themselves, and you have empowered the consumers to discover and access data that they need. So this is a deployment at the highest level, how it will look like. You have domain teams on the left that are data producers. They're publishing specific tables into Tabsdata, which are being consumed by consumers using the subscriber functions. Data teams can build transformer functions that can combine these data sets into things that are more closer to the concepts within the business domain that the organization operates in. And those can become like reusable data sets, data products that can be directly accessed. So this effectively gives you the ability to take away the need for pipelines, empower your data producers to own what they share, bring them into the fold of data strategy by helping them understand what is it that they're on the hook for, and just remove this whole, intermediate firefighting blame game that happens when data pipelines break. It's a remarkably simpler way of doing things that not only reduces the cost, but also increases the efficiency significantly. So I get a lot of, hey, how are you different from Kafka? I can do this in my database. I also already have Delta Live tables. They all kind of sound similar, and that is true. There's a lot of concepts that overlap across these 4 different categories between databases, message brokers, workflow orchestrators, and data platforms. So here's a very quick walkthrough in the interest of time of how things are different. A database, the purpose of a database is storage and retrieval, highly efficient storage and retrieval of information to support applications, reports, dashboards, and such. That's not the purpose of Tabsdata. Tabsdata is effectively helping you efficiently propagate structured data sets. The more important thing is the unit of work in a database is the CRUD operation, the data records that participate in a CRUD operation. With Tabsdata, with Pubsub for tables, the unit of work is actually tables themselves. And then in a database, if you were to manage the history of a table, how a table evolved, you'll have to build that yourself, that implementation yourself. Some databases have that. Some may expose your multi-version concurrency control to leverage history, but those are really specialized, and you need a lot of knowledge to tap into those. That's not the case with this platform. It enables your full version history of the tables that you share. It's not a message broker because message brokers operate on streams. They operate on individual message payloads that require a protocol of understanding between the data producers and consumers. The platform Tabsdata that the Pubsub for tables implementation actually operates on tables as a unit of work. The key difference really between a table and an individual event is that event means something to someone who understands that event. A table is self-describing, fully baked with metadata, and it enables you to use it right out the gate. There are tons of workflow orchestrators for all manners of DIY data pipelines, right? So there's Airflow, there's Daxter on the other hand using data assets. You can potentially build policies to represent contracts. But at the end of the day, these are primarily direct or semi-direct way of implementing empirical flows of data that you program, that you are orchestrating. This is no different from a data pipeline. Whereas Pubsub for tables is fundamentally declarative. You have declared publishers, you have declared subscribers, and when they agree on the same assets, guess what? You have a full flow of information in a manner that is transparent, clear, and auditable. The idea behind this key distinction is not just about the execution model of being declarative versus imperative. It is the data itself. There is no workflow orchestrator that will give you a snapshot of the data at every action, and how it fared. You could possibly create it. It's going to be extremely, extremely hard. And you doing it in a sustainable manner is not going to be easy. So Tabsdata gives you that ability that every single time an action, such as a transformation or a publishing occurs, you have data to back it. And then finally, is it same as my Delta life tables? The answer is semantically yes. It is similar to Delta life tables, but guess where the Delta life tables operate? They operate within the data lake. PubSub for tables is designed to be towards the left. It's a little bit of that shift left semantic that is happening across a variety of tools and infrastructure in the industry, where you're pushing more and more of these inferences and clarifications of how data is effectively utilized down to the source levels. So these tables, even though they have relationships and they depend upon each other and they can trigger based on dependencies, they're operating towards the raw source. For you to use Delta Life tables in a way of table dependencies, where one table refresh executes another table refresh, you have to have the data in. And that kind of puts you back in square A, which is you need pipelines to get the data in. This is a substitute for the pipeline mechanism. So with that said, here are some use cases for deploying Tabsdata. You can automate away things that generally are boring and repetitive and error-prone. You can simplify your overall data integration. But more importantly, because you're empowering your domain teams to share ready-to-use consistent current data sets, you can implement SLAs on top and make them as close to data contracts as you would like to define data contracts in your organization. And when you have multiple of these contracts, you can combine them to produce data products. In governance on top of this whole thing is built in by design. So that's it. We're available on Pipey. Install it. When you have a few moments to play around with it. Documentation is available on our website, tabsdata.com. The product is open core. The core infrastructure is available on GitHub. And we have a Discord channel and a Slack channel to answer any questions you may have. So we hope that you'll give it a shot and reach out and ask questions.